Bismillahirrahmanirrahim. Hi guys, today we will learn about the molecular docking using Autodock Vina. These are the links for performing Autodock studies, molecular docking using Autodock Vina. The first you need MGL tools, and you need to install both the versions 1.56 and 1.57, and these both versions are perfectly working for MGL tools for Autodock Vina. Similarly, you need Autodock Vina exe files. Autodock Vina is in 1.1 version, and 1.2 version is available, and 1.2 version is the latest version that can be used for zinc docking, zinc metalloprotein docking, and 1.1 Autodock Vina version can be used for the small molecule or small ligands. So you need to install these softwares, MGL tools. Let me show you how you will install. First I have checked the MGL tools. So let me copy this link, and on the same time I am using this Autodock Vina link. I will open these both of the links, and this is opening a little bit. The net is slow, so that's why. Here you have MGL tools. In our MGL tools, if you are using the Windows version, yes, most of the people use Windows, so you need to install MGL tools 1.5.7 and this version 1.5.6. both versions are available. You can install both of them or either one of them. Version 1.6 is much stable version of MGL tools, and 1.7 I normally use 1.6. and for superimposability, if you want to redock your molecule, I use normally 1.7 because the superimpose or RMSD value calculation is not available in 1.6 version. So that's why I have both of these versions installed in my computer. Just click on this link and download and then install. It's very easy. So the next is Autodock Vina. Sorry. Let me copy here. Here this is the download web page of Autodock Vina 1.1. So this is the link for the Windows Autodock Vina 1.1.2. This you have to install in your computer in the C drive, and the latest version is also available, that is 1.2, which can be downloaded from the GitHub repository. So I'm going there. You can install this is 1.2. you can install this exe file from this web page. Okay, Vina 1.2 is not installable It is just the exe file. It is not executable file. It cannot be installed in your computer. So just keep it in your directory of where you are doing the molecular docking. So I have used some other way to handle this Autodock Vina 1.2. I have copied and changed its name Vina 2, and I have pasted in my C directory where I have installed 1.1. Let me show you uh, in C program files. Okay, Autodock Vina 1.2 is installed in this way, the Scripps Research Institute. This is Vina. So this Vina, when you will open this file Vina 1.2 will be installed in this directory. So this is Vina 1.1, and I have pasted this Vina 2, that is Vina 1.2. So this is not installable file, that's why I have pasted there. Okay, then what you have to do, you have to copy this link where your Vina is installed, and you have to type in the search bar environmental variable. So when you will go into the environmental variable, use path, edit, and paste over here. I have already pasted here because I am using Vina. So when you want to paste here, click new and paste over here the link. Okay, the advantage of this link in the environmental variable is that you don't need to recall every time directory in the cmd command. Let's say cmd command prompt, you can use just write a cmd over the search bar, and here the cmd command is opened. Let me write Vina. Okay, so this is executable from directly from anywhere in the folder. You don't need to go always giving the path of your files where it is. Otherwise you have to mention this path, C program file the Scripps Research Institute Vina for doing molecular docking. Now here you don't need, you have to write just Vina, and this will give you the, this is saying that the input and search space output. We will use this later. Okay, the next file, OpenBabel. OpenBabel is used to convert the file molecule from PDB to PDB-QT, or mol2 to mol2 to PDB or PDB-QT, or different type of file you can convert using the OpenBabel. Right now I am not installing it, and I don't need to. I think you don't need for right now for Autodock Vina. We will make the PDB-QT file from using MGL tools. Okay, this Perl script, just download the Perl script file. This file will be used for the batch docking. When you want to dock more than one molecule in a receptor, you need Perl and Perl script file. Okay, just install the Perl for your Windows, and this will not show any icon on your desktop. Make sure this will only install in the C drive, and you can check either the Perl is installed in your computer or not. You can check using the command. Let me show you. Perl V. This will show you that the Perl version is installed correctly, and there is no error over here. So it's mean the Perl is already installed in my computer. just to check whether it is working or not. Okay, the next is Vina 1.2 that I have already told you. The 1.2 Vina can be installed from the GitHub. And Chimera, this is the software where I will make my protein. I will prepare my protein over here in the Chimera. Let me show you. Sorry, I'm not well today, so a little feeling cough over here. Okay, this is the page of UCSF Chimera. You can install the Microsoft Windows Chimera 1.16. This is the latest version of Chimera, so this can be installed in your computer. I have installed all these softwares already. I am showing you just where you want to install. This is the Discovery Studio Visualizer. You can install from the given link. Similarly, the PyMol and ChemDraw. You need these softwares to run the molecular docking studies. Okay, we will start the molecular docking study. Okay, in the first, you need a protein. You need a protein or you need a receptor for your compound to dock. Let's say we are talking about the cholinesterase or Alzheimer's disease we are talking about, and we want the receptor for that. So how we will search the receptor for the first time once you want to work over the Alzheimer's disease? In the Alzheimer's disease, you need the butyl cholinesterase and acetyl cholinesterase inhibitor, or for the inhibitor you need both of these, butyl cholinesterase and acetyl cholinesterase receptor you need for the docking. And you can search using the RCSB PDB. This is the protein data bank where a lot of proteins are available, and you can directly download your desired protein from this website. So PDB is protein data bank. Here this is the page where you can from where you can download your PDB file or receptor which you require. So here I am putting the ID of butyl cholinesterase. So just I am putting the code over here, 6QAA. And make the search. Let me open the Chimera. Meanwhile, the file is in process. This is Chimera 1.1 and 1.16 that I have told you that I will prepare my protein over here. So this is Chimera 1.1. So this is still working. Here our protein is 6QAA. Human butyl cholinesterase in complex with S2-butylamine and 2-cycloheptylethyl 3,1H indole. This is the compound, this is the ligand which is attached over the active site of the butyl cholinesterase. How do you know that this is the compound. This is the ligand which is attached to its active site. Let me open the 6QAA to download or to see what is in 6QAA. Here I have opened the Chimera. From here, download files. You can download the PDB format. Okay, this here this is the information about this enzyme. This is the cholinesterase. This has a chain A, which is the main chain of this receptor. Has 557 sequence length. The number of amino acids are 567. So, for your information, it contains chain B, which is N-glycosylation, N-glycoside glycopyranose is attached over here. And in chain C and D, these also are available. These are the small molecules which are attached with the chain A. Over here, this is the chain A. These receptors, these small ligands are attached to the chain A. So you need to remove them before performing the docking. So I was telling you that how would you know which one is the active site of the receptor. Here this is the molecule which is HUN, subject of investigation, means this is attached to the active site of your compound, through which you can find the active site coordinates, and you can make the grid parameter for performing the molecular docking studies. So I have already downloaded the file. We will open in the Chimera. Okay, in the Chimera we have one advantage over here. You can directly open the PDB file which we have downloaded from the protein data bank website, and you can fetch by the ID over here. You can write just QAA and just click enter, and you will get this protein directly from the internet using. Okay, what we have to do with this protein? Okay, first of all, understand the use of the mouse. For Chimera, when you press the right button of the mouse, using the right button of the mouse and moving the mouse up and down, you will make your receptor smaller or bigger, and using the left key of the mouse you can rotate the protein. Okay, now we will check. Here we have already seen that A, B, C, D, these are the chains available. So I need to keep the chain A, where I have already shown you that in the chain A our active site is available. So I don't need to retain other chains. So I have to remove that one. So how to remove the other? I have selected the chain A, then select invert all models. Other than the chain A, all model will be selected, and I am removing from the action atoms bond, and these have been deleted. So in the chain A, a lot of other non-standard residues are available. How to check those residues? Which residues are available? Select residues, and here DMS it is available, which is as also a small molecule, we also have to delete this one. Okay, let me delete one by one. Select residue. This is a water molecule. I am also deleting. I don't need over here. These all steps are the preparation of protein for molecular docking. Here I have kept the active site molecule, which is over here. This is our active site. The active site where we will remove this ligand and we will dock our own ligand, which we have prepared. Or right now, what I am doing here, I will redock this molecule in the same receptor. I will separate this receptor. Okay, you are watching here that I didn't remove NAG. This is N-glucosamine. This is attached to the receptor actually, that's why I didn't remove. This is a main side chain component which is stabilizing the receptor, so I didn't remove that. So clear selection. I am selecting over here Hun, so I will delete this once and save my PDB file which I needed to proceed. 6Q AA .pdb. I am saving in my molecular docking folder. Okay, clear the session. Now again I am opening this. I have re-downloaded. I need the receptor. I need the molecule which is attached on the active site of the receptor. So how to choose that? I am selecting the molecule which I have to retain over here, and I will delete all the rest of the chains. How I will do? I have selected this and select invert all models. So action, atoms, and delete. Here you have only the molecule which is inbounded with this receptor on the active site. So I will save this molecule to these both receptor and the ligand, which I will redock in this receptor to check or to optimize our docking parameters. How you will prepare the PDB-QT file? You will open the Autodock tools 1.5.6. 1.5.6 is much stable than 1.5.7. 1.5.7 has a lot of bugs, so I am using 1.5.6 and I recommend to use. Let me prepare over the PDB-QT file. Go in the file, read molecule. First of all, I'm sorry, I didn't told you the first step. using MGL tools. Go in the file, set preferences. You need to set the directory where your molecular docking receptor and the ligand are there. You have to set over here. I have already set it there. So make default and press set and then dismiss. So whenever you want to run any molecule, you will directly go into your directory. Here you have seen that I am already in my directory where I want to be. So I have saved my receptor 6QAA prep. So I am opening over here. You can see this receptor. When you will open your receptor using the file read molecule and you have opened this receptor, the next step is to add the proton hydrogens. I am adding the hydrogens. I am adding just the polar hydrogens only. Okay. Let me tell you one thing. When you are using the Autodock tools or Autodock Vina, there is some differences in both of them. What is the difference? The difference, when you will use the Autodock Vina, it will neglect the charges which you have already added, compute gesture charges or Coleman charges. It will not take your charges. If I will assign over here the charges to the molecule, it will not affect the molecular docking studies using Autodock Vina, because Autodock Vina has its own scoring functions and it will calculate its by its own. So I have only added over here polar hydrogens by using this option. You don't need to do anything else. Then what you have to do, this is the file PDBQT file I am making over here is for Autodock Vina, not for the Autodock tools. For the Autodock tools you have to add the charges, you have to assign the atom types and some other things you have to do. So I am not using over here because Autodock Vina is much more speedy rather than Autodock tools 4.2. So I am just making the PDBQT file over here. Okay, you can make also PDBQT file using the Autodock Vina too, because Autodock Vina, sorry, not using Autodock Vina too, ADFR suite. I will let you know what is ADFR suite, which can be used. You can use the CMD command prompt over there. Let's say I have already installed the ADFR, so I will just write over here prepare a receptor. I'm sorry, I think it's didn't, sorry, prepare so this Python command is already in my ADFR suite. I have installed in my computer. Let me show you where it is. Meanwhile it is downloading. I will tell you where I have. ADFR, the benefit of ADFR suite is you don't need MGL tool 1.56 and 1.7. It has built in over here. You can download the ADFR suite from this website. This is also from the Scripps Research Institute. So you need to install in your computer you will have, when you will install, you will have this AGFR. AGFR is auto site finder. It also contains the site finder. When you don't know what is your binding site in the receptor, you need to find using this ADFR tool. Let me, this is another topic. So when you will install the ADFR tool, you can directly prepare the ligand using this command. You can see when you want to make prepare receptor, I have here it is saying you need to add, you need to prepare PDB and PDB-QT file, and when you want to add output, this is for output dash o PDB-QT file, what you want to name your molecule, that I have named 6QA underscore prep dot PDB-QT. If you want to preserve the charges, preserve the specific charges on the atoms, zinc, iron, or if you want to merge charges and remove non-polar hydrogens, merge charges, these are the commands you can use using the ADFR, and you have to make your PDB-QT file over from directly CMD format. You don't need to install MGL tools then. So this is much easier way to make the PDB-QT file. Okay, what I will do the next, I have done already, I told you that I have added the polar hydrogens over here, so I don't need to add the charges because Autodock Vina has its own parameters and its own way of calculation these force field calculations. So the next is I will choose grid, choose, and I will choose this one. It will initialize the window and it will open the file folder for to saving the PDB-QT file. So I am saving over here PDB-QT, your receptor name and PDB-QT saved. Okay, next you have to delete all molecules. You don't need over here, so I have deleted for making the clear picture to how to prepare the receptor and how to prepare the ligand. Whenever you want to prepare the ligand, you need to open the file in the ligand. Open the ligand here, the PDB file. I have saved the 6QAA HUN, which is in bounded ligand in the receptor. Butyl cholinesterase receptor was there. We have already, I have already told you. Here you can see it is saying that added Gasser charges found 8 aromatic carbons, detected 14 rotatable bond, set torsions, it is set it the torsions to 13. So this is your molecule which was attached to the active site. I will make the PDB-QT file and redock this molecule in the receptor site to check whether my optimized conditions are good enough or not. So torsion tree, detect root, choose root, choose torsions. Okay, set number of torsions, I am putting over here 0. I don't want to move the much molecule because a lot of chains are there to move. These are the torsions from where it can move. So I am making it 0. Okay, then ligand output save as PDBQT. Okay, the next step is I am removing from okay, when you want to make the grid parameters a configuration file, you have already made it, the PDBQT file. Okay, you made the PDBQT file of your ligand, and you have made the PDBQT file of your receptor. The next step is you want to make the configuration file. Here, these receptor, what is your receptor, what is your ligand, you have to put the name over here, configuration center, these centers, size, energy range, exhaustiveness, number of modes. I will tell you in how to find these coordinates. I will again use this MGL tool. How you will find? First of all, you need to open your molecule in the grid. Macromolecule means your receptor. You need to open your receptor over here. Then you need to choose your receptor for the grid. You want to make the grid on over here. Then you need to open set map type. You need to open your ligand for which you want to map your parameters. This one is your ligand. So again, you need to choose ligand, double click on, and then you need to make the grid box. Here is the grid box. You can see the grid box over here. I think all of you can see the box around the receptor. Okay, please check that this box is out of this ligand. So I need to make the center of the ligand. Center, then center on the ligand. So this is now in the center of the ligand. So these are the parameters which I will use in my docking. These are the dimensions through which you can make your grid parameters map. You can increase or decrease your box size. So I have to set this to 30. Okay, if you the maximum map size should be 30. If you will increase the size, you need to increase your exhaustiveness and number of runs for your molecular docking. So 30 is enough. Here is the spacing in angstrom. You need to I am putting here the default value because the 30 is also the default value, so I am putting here the 30. Now you need to save output grid dimension file. I am saving this grid parameter which I will use in configuration file. This is our configuration file. So let me change over here. This is 19.038, 42.713, and 39.530, 33. I have already done because before this session, so I have already included these values, so I will just save the file. I didn't change the ligand name. What was our ligand name? This is our ligand name. We copy this ligand name and put over here. 6QAA1 is our ligand name. So I am saving this configuration file which I will use in the docking. So this is energy range. What is the energy range? Energy range is the difference of energy in each run. Exhaustiveness is 8, which can be maximum 32 in Autodock Vina 2 1.2. Exhaustiveness means in the each run, for the each number of mode, for example you have set the number of mode 10, means Autodock Vina will give you the 10 different poses, the best poses. In each pose, the number of time your molecule make its own configuration or own conformations is exhaustiveness. For example, it is given the mode 1, number of mode 1, so it will rotate or it will make conformation to fit in the receptor active site. It will how many time the molecule will change its conformation to set into the active site of the receptor. That is exhaustiveness actually. When you will make this size x, y and z, when these are the 40, then you have to keep it 32 at least. So I am putting over here is the default value 8, and I will save this. So how we will perform the docking? I am closing these CMDs. So another I will tell you the trick to open the CMD command. CMD, you have to write in the search bar CMD. You will directly go to your directory where your molecular docking is. Otherwise you have to mention the path where your file is. So even the Vina is also over here. I can use Vina in directly from this directory because I have already added the environmental variables of this program. So I am putting over here the Vina conf dot config conf dot text. This is the configuration file actually. Log dot text. Okay, I think there is some issues. Okay, it is saying that Vina 1.2 do not need the log text, so I will only add Vina config conf dot test. This is your file where you have given the coordinates, you given the grid box size and everything, your receptor name, your molecule name. So you don't need to add some other things because Vina 2 is much efficient now, so it don't need much things. Then I have earlier put it the log log.txt. This will save uh, the number of runs. So this option was available in 1.1. So here it don't need, Vina 1.2 do not need. So I will just enter. Here it is computing the Vina grid. Here you can see the grid center. We have already set it in the configuration file. These all the information we have already given in our output file. In our configuration file. The output file will 6QAA underscores HUN underscore out. This was our this was our output file. Output file means your PDB, your Vina results, Autodock Vina results. Once it is performing, what I will do is this is Vina 1.2. Here you can see minus 9.8.27. The ranked one, I have given the number of mode 10, and this is the first mode. In the first mode, minus 9.827, this is your best pose, which Autodock Vina has docked our molecule in the receptor. So minus 9.87, the higher the negative value, higher the binding affinity. This is showing to the affinity to the receptor. So minus 9.827 is an energy through which it is binding to the receptor. So it has been already docked. Let me check where we have to open this file. In Chimera, I am opening these results. Go to the tools, then surface binding analysis, and then open the view dock. So this is in E molecular docking. This was our out file, docking results. Here you can see your compound, which is 9.827. This is run 1. And when you want to check other mode, these are the modes which the Autodock Vina has given us. So you have to these are the Vina's result. Okay. Minus 9.827 is the best mode. Now we can see how it has interaction with our receptor. You need to open the receptor over here. You can see the receptor and the ligand which we have docked. Okay, let me show you the molecule which we have. Okay, I will tell you the later. This is the receptor 6QAA, and this is the docked ligand. How you will check the analysis? It has made which type of interaction it has been made. Uh, Select residue. What is your residue? This one is residue. This one is your docked ligand, and I have already opened the docked result. So this is your docked ligand. So what you have to do next? Tools, surface binding analysis, find hydrogen bonds. We will check that it is making hydrogen bonds or not. Here these are the parameter, hydrogen bond parameter. I am saying that it should have label the hydrogen bond with the distance, and this is the hydrogen bond color. You can change directly from clicking here. I am not changing the color. So this is the relaxed hydrogen bond constraint. It will show you the results. The bond which is hydrogen bond which is in distance of 0.4. So I am making this one. So it will show you the hydrogen bond near to the receptor in distance of 1 angstrom. So here color hydrogen do not meeting precise criteria differently. So let me only hydrogen bond apply. Okay, now see over here, it is not making any bond with the with our receptor. So if it is not making hydrogen bonds, it will make the electrostatic interactions. How will you will check the electrostatic interactions or pi interactions? This software is not suitable for showing the pi interaction. Discovery Studio is the best software which will tell you the 2D interaction diagrams. How you will check? First you have to convert your files in the complex form. How you will make the complex pi mole? You need to use the pi mole. Okay. Here this is the pi mole, which is the educational version. You need to open. You need to go to your folder. Here is your protein and your docked file. This one is your docked file. This is your receptor. You can see your molecule. You can show and bold. You can learn the pi mole through YouTube channel. A lot of videos are there how to use the pi mole. You will see that from there. Select object using the right click option of your mouse. So this will select this object. I want to select this object. This has been selected. I want to rename the selection. Action, rename. A for action, S for show, H for hide, L for label. Okay, I am changing the name. Enter. So I need to save these both complexes, ligand and protein. Now I have opened these two sorry, I have to save molecule 6QAA and Hun. So one file I want to make both in one file, .pdb. So I have made the ligand and protein complex. So now I can open in Discovery Studio to show you the 2D diagram in which you can see it was not making the hydrogen bonds, but it was interacting through the protein using pi stacking or van der Waals forces or some different different interactions. So what I have made the complex, this one is I made the complex using the pi mole. This is this one is your molecule. So how you can check? You have to define over here receptor and ligand. Here the ligand is not defined over here because I have not selected the ligand over here. So I will select the ligand. Here HUN, this was our ligand. You can see over here I have select this one and then define ligand. This will take your ligand over here. Okay, now you want to check the ligand interaction. You can also draw a 3D diagram using this Discovery Studio pi mole. If you want to label this one, you can use. I am adding the labels. How you will add the labels? Right click in the beneath of this table, add labels, object. I want to add residues. Object was residues, and I am saying it should add ID and insertion code. So the color should be yellow and font size Arial. You want to change as per your requirements. Apply and OK. Here you can see, I'm sorry, this this one is. Here is the interaction between the receptor, and these are the residues, amino acid residues, tyrosine 332, PHE 329, and some other, histidine 438. These are the interactions, the molecule, the unbounded molecule shown to the receptor. You can check using the 2D diagram what actually it is making, pi stacking or some other interactions. You can just click over here, show 2D diagram. It will show you the 2D diagram. Here it is saying that it is making the conventional hydrogen bond. Maybe in the chimera we didn't found this hydrogen bond over there. Discovery Studio Visualizer, it will show the every type of interaction. So I recommend using Discovery Studio Visualizer to make the interaction diagrams, just to check what type of interaction is your molecule is making. And you can see over here the interaction are shown in different colors. The hydrogen bond is in yellow color, carbon hydrogen bond, pi stack. These are the different interaction which is your dog molecule is showing. So whenever you want to save this one in an image for your result studies, for your paper or something else, you have to drag this molecule over here and just save as image file. I'm saving the image file. Here you can increase the pixel size. I'm making 2000 and it is also 2000, so it will show you the high pixel size image. I have saved in my folder, so I will check it later. So the time is running. What you have to do if you want to dock your own molecule which is not in bonded molecule, I mean which you have synthesized, and for example it is showing the butyl cholinesterase activity, for example. What you have to do, you need some molecular dynamics to minimize the energy of your molecule before docking. So how will you minimize? I am telling you the website can compute. This is the website where the games, these are the software which is used, which you can use for the molecular docking. Not for the molecular docking, for the setting the parameters or computing or minimizing the energy of your molecule using the GAMS. Here you can make your ID over here in the GAMS. How will you use this GAMS? GAMS is a software for molecular dynamics. So you can directly submit your molecule over here. It will automatically minimize your compound. I'm sorry. It will energy minimize your compound. You can draw your molecule over here. For example, I am putting here the toluene. I want to minimize. What when I will draw this molecule, I will just transfer. So you can see here it is optimizing using the MMFF force field. So you can see it has changed its orientation and it has done its symmetrization. Then you need to use what you want to use. Select your package GAMS and basis set. What you want to use the basis set. Normally for the small molecule you can use these both of the set, 321G and 631G star. So I normally use this one. And for if you have complexes, so you need to SPK TPs that you can use. Type is what I want to do is I want to optimize the geometry of the molecule. So if you have the best geometry, optimized geometry, it will gives you a better result in the docking. If you do not do this procedure, maybe your results will not be accurate. So I am on the molecular orbital method. So this is I'm not selecting anything else. DFT method, B3LYP. Then you need to here the processor core element time is 1 hour. What do you mean by time limit. This time limit means if this job will be done in the 1 hour, then you will have the results. If this molecule will take much more time, you need to log in and register, it will give you up to the 8 hours. Here the memory is default for if you are not registering in this website. So I will recommend to make your account over here and then use this web page. Then directly you need to submit your job. When you will submit your job, you will get this job number. So save this job number, and when this job will done, you will get the output file. This output file can only be opened in Avogadro software, not in every software it will be open. So use the Avogadro software where you can make the PDB file, and then you can use MGL tool for further preparation of PDBQT file. So I think the session should be interesting, and you have learned a lot. Thank you very much.